Start now. So what the point is, I was just discussing that we are not going in depth through the chapter wise because it's so much of lengthy chapters. Okay. So I just took up the first question and trying to solve it through somehow, and I took some help from outside. So I'm just going to share the knowledge I have. So then from there we can pick it up. Maybe others can also support on this. Yeah. So this is the first question. Okay, it came in. You can see the screen, no?
Yeah.
The 2020 number one. Okay.
Yeah.
So this question is actually a simple question, but it's a bit of trick. Okay. So it's saying that consider the following DN is a deep neural network for image classification for a dataset that consists of RGB. Let me see. I started recording. Yes. Okay. For RGB image size of 32 by 32. And this is the if you see this one, this is the Keras codes to do this deep learning. Okay, so here we have model sequential is the by default they are using this one. It's like one by one it will process one layer, one next layer, like that. Then model dot add layers, dense, activation and all. Just we will keep it like this. We will come back after checking the question. So here we have dense 40, dense 30, activation, ReLU, shape and all, dense, activation C. Okay, one thing I want to add here is if you see this one, dense 50, this 50 means it's the number of, you already know this neural network, no? We already learned it in the machine learning.
Yes.
Yeah, in that machine learning, okay, so this is the number of neurons per layer, okay. In this first layer, they are going to add, okay, this is layer 1, they are going to add 50 neurons. The layer 2 they are going to add 40 neurons and then 30 neurons. So and the activation is ReLU. You know this ReLU, no?
Yes.
Okay, fine, great. Yeah. So coming to that, the question is what is the input shape A in the layer 1? So this is the layer 1 and they have given an input shape. Okay, so they have already mentioned RGB size of 32 by 32 pixel, right? So the answer they have given by the university is 32 into 32 into 3 or 3072. You can guess what this one is, right? Anyone?
It spreads the entire pixel structure into one tall, skinny column, maybe.
Right, yeah. So I have put, this is my detailed answer for understanding. So this is the black and white image, okay, and then this is a grayscale, and then this is the RGB. So we'll start from maybe everyone knows this thing, or is it new to someone, or should I explain this?
You can. It will be better to have another perspective.
Okay, fine, yeah. So this is the black and white picture of 7 by 7 pixel, okay. In this question we have 32 by 32, right? 32 by 32 pixel of RGB. But for example, first one we are taking 7 by 7. And what does 7 by 7 means? It's a 7 here, 7 rows and 7 columns, okay? 7 pixels. So each one is a pixel and it's a black and white. So it can be either black or it can be either white. So 1 is black and 0 is black and 1 is white, okay, here in this case. And if you take it as a matrix, this will transform like this. Is it okay? Are you able to understand? Is it clear?
Yeah. So you have made this as a matrix. You try to show it,
Yeah,
the smiley as a matrix, right?
exactly. This is a black and white. Okay, there's only black and a white. Either it can be 0 or it can be 1. So this can be represented by a single bit. Okay, for 1 pixel we are using only 1 bit, right?
Right. Yeah.
Okay, great. So you understood the black and white thing, 7 by 7 pixel thing, right? Everyone okay?
Yeah.
Right, yeah. So let's yeah. Okay, so let's go to the grayscale picture now.
Why it is 7 by 7?
I just I mean in the example I searched on the website, they are giving 7 by 7 pixel. It can be any like in the question we have 32 by 32. We, for example, we took a 7 by 7. It can be 5 by 5 or whatever you want. Yeah.
32 by 32, there is no equal to split, is it? 32, 6
Sorry, what?
cross 4.
Sorry, what?
Okay, they have given 32, right? So it is not 6 cross 4 is it? 6 4 are 32.
No, 32 means 32 rows and 32 columns.
Okay.
It should be 32 rows and 32 columns, okay? And yeah, this 3 we will come to once we learn this RGB. So now, no, this is for our study purpose. We have taken 7 by 7. It's not related to the question.
Okay.
Okay, let me type it here. 7 by 1,000. Okay. Not related to the above question. Pixel size not related to the above question. Okay, so we have, yeah, so grayscale, next is a grayscale. So you can see the here it is white and here it is black, right? These 3 are white and these 3 are black, and then we have the shades of black and white, right? So let me read this. Each the values we are representing is 0 to this black is represented as 0 and white is represented at 255. So any value in between is a shade of the gray. So here you can see it's represented by 38 here, and then 77, and then 128 for this gray. And likewise, you are increasing the values while it reaches the white as 255. So this value shades of gray is represented from 0 to 255. I think everyone knows this one, right? Any, yeah. Any doubts? Let us do once again. Okay. It means the picture with luminance only information. That is a picture with no chroma information. There is no color here. Only the luminance. The intensity is changing. For standard dynamic range images, yes, 8 bits is the typical for grayscale. However, that's not a requirement. You can have a grayscale of any bit depth. See, here we have used 0 to 255, but it can be from. This means 255 is like 2 raised to 8 bits. That is right. 2 raised to 8 is a 256. So 0 to 255 means 256 values. But it can be like 2 raised to 16 also, 2 raised to 24 also. But in the standard way, in the grayscale is represented is by 2 raised to 8, and I think this is enough. But normally this one is done. So generally we are using 8 bits, but it can, this value, individual values can be anywhere, can be of higher value also. So you will have more gray, shades of gray in that case. So that is also understood, right? And this one is represented as a matrix. These values are taken as with comma and 2 bit square bracket. It becomes the matrix for the grayscale. Everyone is on the same page. Everyone understood this?
Yeah. Okay.
Okay. Yogi ji.
So Manoj,
yeah.
Manoj,
Yeah.
So the grayscale that you mentioned, is that it's a concept that you're describing, or is this in relation to the question?
No, this is a concept actually.
Concept.
Yeah. Trying to understand the concept of grayscale not related to question. I'm trying to come to the RGB because maybe when you said, so this one is clear, no? This matrix becomes like this for the grayscale, yeah. Next is the RGB. So RGB, what happens is each pixel, again we have the 7 by 7 pixel. Each pixel is represented by R, G and B. So 3 layers are there, okay, like 3 layers. So in this one we had only 1 layer. The value is straight away is represented in the square matrix. But in the RGB, what happens? We need to represent like this. Each pixel has to be represented RGB, R value, G value, and B value. And we know that when we add all those in equal proportion, it becomes white, and a lack of it or 0 in each will be black, right? And a proportion of ratio of different colors is the ratio of different RGBs. So is this clear?
if someone needs to know more, because this might be new to many people, if it helps, I don't know, I'm not from this field exactly, but I read this long back in electronics magazines, which I used to type. These RGP or maybe processing images, you can learn more on about CMOS. If you can search anything, if I'll get time, I will search the CMOS topic. So what the CMOs do, they get the lights from the environment, and every intensity, like this pixel, if Manoj, if you can see, just scroll down a bit for this three-dimensional matrix here you have, no? Yes, yes, for this one. No, no, this one, yes. So this hut, which you see, the sun is depicted by yellow, the top of the hut is by red, the ground is with green. So every camera works in a way like this. So when we see that 70 pixel or 100 pixel, like these images are created, these are created with CMOS. That every ray of light, it is registered in those CMOS, and the CMOS splits all those in their own registers. So red, green, and blue, there might be other channels as well. When we see, if someone has tried to use Photoshop, or maybe in somewhere in your pictures you might have seen, there are like other image structures where they use cyan as well, like in printing technology they use cyan as well, black and blue and other colors. So when you read those topics, you will understand how these images are created. And exactly what we do in the deep learning here is we split those channels into individual channels. Like red is splitted separately, green is separately. But in when you get the picture from the CMOS, it is not like that. It is a combination of all these channels. So computationally it is made so, like you can split it using what you can call it, these Fourier transforms and other transforms, where you split signals. Like that algorithms are used to split these colors. So I'll try to get this material from online. I read it back in some magazine, like Electronics for You. It was published way back in like 2004 or something. But it was a very good article. I think it will be very helpful if I can find it somewhere. Okay. So yeah, you can continue. You can share the screen. I mean,
Yeah, sure, sure.
So basically, we are splitting into is the primary colors, and each combination of our primary colors is shown as an image in the matrix.
yeah, but in actual, when we are discussing in question papers or say in the course, it is so very basic that it seems very intuitive that okay, we are splitting these red colors and green colors. But in actual, when you apply this deep learning, it is not so intuitive. You have to actually compress the image. You have to make so many transforms to it that sometimes you get confused, like if the image is compressed so badly that you cannot recover the image, you know. So
Okay.
these things have to be taken into consideration. But
Yeah.
this is good intuition when you're telling about this example, with this example.
Okay. So
But if you're
yeah, yeah.
saying, just one question, if you're saying 1024 pixel, right? So
Yeah,
what would be the matrix sizes?
the
Uh,
matrix is evenly distributed. 1024 pixel means it is both horizontal and vertical. Yes.
okay, okay. Just square,
Yeah.
it's square always.
Yes, that's the squares.
Okay, okay, got it. Okay.
uh,
Okay. So what we are trying to understand is here is how the pixel is represented in a matrix. So here I think everyone understood now how this matrix is created, right? So each pixel here, for example, if it is red, so yeah, they have taken sixth column, third row. Let us check it out. Sixth column and the third row. So it is sixth column and third row. Yeah, so sixth column and third row. So it should be this one. and it's 100, 200, 100, 220 and 230. So in this way we are representing each pixel, whereas in the grayscale we had a single value, but here for each pixel we had a single value in the grayscale from 0 to 255 for 8-bit pixels, whereas in the black and white we had a single value 0 and 1. In the color GB color we are having 3 values. For 8-bit we are having 0 to 255 for R, and similarly for G, and similarly for D, and this different combination represents the color that you will be seeing in the screen. So here the question was, I think this is clear, right? Everyone has understood this one, no? Because we just need a high level of understanding only. Is it okay or what?
Yeah.
Yeah, Manoj, it's
Yeah, fine.
Okay.
Yeah. So then we can come to the answer. Like 32 by 32 pixel RGB size matrix will be 32 into 32. That is the rows and columns. 32 columns, 32 rows, and then 3 for the each one. So each value will be. So it has to be in the third dimension, right? So it will be 3 here. So that will be 3072. 1024 into 3, 3072. So this 3072 somewhere I found it is called flattened to a single dimension. This is a 3-dimension thing, and this flattened to a single dimension. So it's one row with so many values. So this is the answer to that question. So the question was, what is the input shape in the layer 1 when you have 32 by 32 RGB image? So this one is clear?
Yes.
Anyone has doubt on this? It's a very simple one. Okay, I assume everyone knows, so we can go ahead.
Just one thing I don't know, maybe it's a very stupid question from my end, but the input shape, when we make this skinny column of this complete picture, this 32 by 32 matrix, when it is made into single column with 3072 input, what you call it? Okay, well, let's call it input only. So when it is 3072 input, how do we map it? I mean, these sequential layers are added. Do they even ask questions where we have to map these every input with these layers? I mean, I'm not able to form the question properly. Say, for example, this first layer, the number of neurons is 50. Okay, so when the image size is 3072, how do they get mapped?
Wait. Yeah, I think I got it. Yeah, like see the image size. They are asking what is the input to the layer 1. Okay, there is an input layer first of all, and then we have the second hidden layer. So layer 1 is a hidden layer. Okay, and there is an input layer before that, and the input layer is having 3072 inputs. This is what I understand.
Yes.
So in that way we are connecting from this all 3072 into the 50. So each pixel will be connected to the 50 neurons.
See, these 3072 maps to every single
Neuron, yeah,
neuron. So
exactly.
into 50 will be
The input, yeah. That we are
Yeah.
coming in because the question is there, so we will come into that. So the point is here, what you asked is the dense, because it's a dense, it will be connected to each and everything. That will be complete connections with separate weights for each connection. Now we are coming into that. Now let's go to the second question.
okay.
So what will be the value of B star star activation function C star and dose D? So this star B is nothing, just instead of question mark they just put some and to identify B, C, D like that.
Yeah.
Okay, so here we have in the input shape they have mentioned A star, that already we got. Okay, so this is 32 by 32 into 3 is the shape of the matrix that we are going to give into the system. And now they have made the ReLU as the activation for this first 50 neurons, and the second layer is 40 again of ReLU, third is also ReLU, and the fourth one is the output. So because from here we know that output is the output layer, final one. So here B star, so actually the first parameter is the number of output. if you check the Keras code, the layers.dance in the bracket, the first parameter to be given is the number of output. So let's see here the question once again. If the total, what will be the value of these parameters if the total number of classes in the dataset is 2? So number of classes in the dataset is 2 means the output will be 2 only, right? Is that clear?
Not sure. I mean,
Yeah, number of,
Yeah, it can be, I think.
no, it is sure. It's like that only, because
it's
total
2,
number is 2 means the output can only be 2. It cannot be more than 2, right?
Yeah. Yeah.
So I mean, in the
They're
normal,
trying to classify.
yeah.
So classification is like by like 2 types of output.
Yeah, if the total number of classes in the data is 2, so we are taking the output as 2, right? So how many nodes is required here? This B means number of nodes in the output level. Yeah, so here we have 13 nodes. So similarly here we should specify some number of nodes here, and as the output is 2, number only
one
one node is required, right? Yeah, that's the point here. Okay, so in the university answer they have mentioned 1.
But
Yeah.
But following up with my last question, no, this made me thinking, Manoj, I mean, if you can see the question again, I mean, did they give any input image in the question or not? Just that the idea that we have a 32 by 32 pixel image. Did they give any sample image in the question?
No sample, only the shape is
Sample
given.
image.
Yeah.
Okay.
So we will see if you think too much now, you will be will go astray now. So let's just
Oh,
focus
because
on something. Yeah.
this time I'm asking this because there are sometimes trick questions which they might be asking. So just to
I think this is a straightforward question anyway.
yeah, this is very straightforward. Now
Yeah.
I am clear.
Yeah. So this first one we already understood now, the number of neurons, and it has to be 1 only because output is only 2, right? The 2 is given in the question. Yeah. So second is the activation function. Here we have the ReLU, and we know ReLU, right? ReLU is something like this one is sigmoid, no?
Yeah, this one is yes.
ReLU will be like 0, and then for the negative values, and then it will be linear for the
X equal to Y kind of.
yeah, right, exactly. So ReLU cannot be used in the output because we need only 1 and 0, right? So we can use the sigmoid. So answer is sigmoid for the C star, right?
Yeah.
And then we have the loss. The loss, Keras loss is mentioned. These are the 3 losses in the Keras. I got it from this link. So binary close entropy is the common one, okay? While hinge and the squared hinge are used for the SVMs. This is mentioned in this link. So we are using binary close entropy for this loss function for the D, right? So let's have a readout on what is binary close entropy. Is the default loss function to use for binary classification problems. It is indeed intended for use with binary classification where the target values are 0 and 1. Mathematically, it is the preferred loss function under the inference framework for maximum likelihood. It is a loss function to be evaluated first and only changed if you have a good reason. Close entropy will calculate a score that summarizes the average difference between the actual and predicted probability distributions for predicting class 1. The score is minimized and perfect close entropy value is 0. Close entropy can be specified as a loss function capable of specifying binary close entropy. This is the parameter that we need to give when compiling the model. So take it as a rule for images binary classification deep neural network. The best loss function is binary close entropy. That's done. So hence answer for the output for only 2 outputs is model dot at layers dense 1, whereas 1 is the number of neurons. Activation is sigmoid, and the loss is binary close entropy. So this completes our second question. Is it clear?
Yeah. Yeah. Okay.
There are, as per this we have only 3 options for losses that's available in chaos, and First one is the one by default we are
But
using.
hinge and this third one, the
Square hinge.
square
Yeah.
hinge, like it is strictly for the SVM or algos only.
I don't know because in this link it's mentioned in this way. I was just searching why we are not using this.
Oh,
So it
okay.
is yeah, it's mentioned in this way. And this is cross entropy is the binary cross entropy is the default to use unless you have a good reason to not use it.
Mm-hmm.
So this is what the other person also tutor also told me about. Mm. So then the B part is having one more question. What will be the value of the B, C and D if the total number of classes in the dataset is 10? So again, here we cannot use the sigmoid, right?
Yeah.
We have to use maybe 10
No, we
sigmoids.
cannot.
So it's called softmax. See, first of all, we have to use this one. This is a number of neurons. Number of neurons has to be 10 because it's the output, right?
Yes.
We need 10 different classes, right? So 10 is the now this is the first answer. Second one is activation function, and we are using softmax. Softmax is
Full form.
used, right? Softmax. Let's check what is mentioned for soft, which means layer 4 is the last layer of the code, which means outer layer. In this question, we have 10 output, hence segment cannot be used. Commonly used is the softmax as mentioned here. The output of sigmoid function was in the range of 0 to 1, which can be thought of as probability, but this function faces certain problems. Let's suppose we have 5 output values 0.8, 0.9, 0. So each is giving something different like this. How can we move forward with it? We can't. The above values doesn't make sense as the sum of the classes output probability should be equal to 1. You see the softmax function is described as a combination of multiple sigmoids. So softmax is a function that is having a combination of different multiple sigmoids. It calculates the relative probability similar to sigmoid logistic activation function. So it returns the probability of each class. It is most commonly used as the activation function for the last layer of the neural network or the multi-class. See, if you see here, this is a simple one. Zi divided by sum of the Zi. Zi is the total of the outputs. Like each one is having 0.8, 0.9 like this. Then it will add up everything as a denominator, and for each one it will check the probability, right? And in this way it will make it from 0 to 1.
Um, I, I mean, please don't mind. We are 11 of us here in this meeting. Uh, I mean, like, this question is not related entirely to this particular explanation, but just a general query. Do you guys have like intuition, good intuition, or maybe you must have? We are learning all these functions, say exponential function or gamma function or beta function. Is it me, or is it the general problem that we don't get exactly what form it will take when we plot it? I mean, like, I face this problem a lot, especially during the exams when there are solutions where it says, okay, we are going to use this function, say exponential function, and it doesn't very easily, it doesn't come very easily. How on earth they just say it, okay, exponential function, we are going to use it. I mean, there can be any other function, say sine function. If we tweak the sine function, that might give the same plot as an exponential function. There are many ways to tweak an exponential function, but why an exponential function? So do you guys have the same problem while studying? This is general query, not related to this explanation, but just asking. We are 11 of us, so maybe this some of you can help me with this. This is very, very big problem which I'm facing at the time when I read these books on ML and data mining.
You mean you want to understand how to do this exponential thing, calculation, or what?
Not exactly calculation, but see when see for this softmax, for example, softmax says it is exponential of zi divided by summation of exponential of zj, summed over j. Okay, so there might be like 10 neurons. There are 10 neurons, each with their own values, and we are trying to take an exponential of all that, and then we are going to sum it and divide it by that particular neuron. That will give us the softmax value. But how does this value get significant in predicting the output? I I mean,
Yeah, so the point is here to find from 0 to 1 values. Okay, so the total will be 1, and in that way we will find which is the maximum, right? So that maximum will be the output class.
so every neuron is being checked like that, no? I mean, it is already in the probabilistic form, like point 0.8 is given, point 0.6 is being given out with by each neuron.
Yeah.
Ah, but then we are again calculating a softmax by dividing it for another summation. Like I I don't know, maybe I'm not able
Here,
to follow.
yeah, the thing is, in the previously, like in the input will be like 0.8. Some the probability will be 0.8 for example, this is cat, this is dog, this is something else, right? So
So we can
probability
take the
of,
point which is very high.
yeah, yeah,
This is intuition, no?
yeah, yeah. So there is some other requirement. I'm not sure exactly. I don't know how to. I didn't actually. I'm not a great expert on this, but yeah. So this somewhere I read that if you add everything here, it will be more than one.
Okay.
So the
Okay.
probabilities has to be within one, no? The probabilities should be
Okay.
equal to one. So that's why they
Yes.
are making this calculation and making it 0 to 1. So each output will be from 0 to 1, and then the function return 1 for the largest probability index, while it returns 0 for other two array indices. For everything else, it will be returned 0, and only the largest one will be
Correct.
taken as 1.
Correct. Exactly my point. But whenever they need something like probabilistic range, within probabilistic range, they will come up with something out of the box, say like this particular equation. They will come up with anything that can bring that whole calculation to within the range of 0 to 1. But it is not very intuitive for me, for someone who has completed college back in 2012, and I have not used these many mathematical equations in so many years. I even started to doubt whether I should pick up my college books and start learning all those SOAPs related to plots and functions and real numbers. So you getting my point? Like they will come up with
No,
any
you are
equation.
asking why you
They
are
will,
using this one. No, that's
yes,
your point.
exactly,
Yeah,
exactly.
that
They will
we
give.
cannot answer it in this way because we are trying to get the oral picture, or what is a high level picture of the what we need to learn in the DL. No, to answer the questions. In the questions, uh, the way you are asking is like a PhD level of stuff. Which why you are using this one? I don't know anyone can answer this one. Why you are using? Because that needs some explanation, some understanding of the
Yes.
whole stuff. It's not like shortcuts, right?
So we are supposed to learn it because it has been proven over the years, right?
Yeah, maybe. Just see, what I did is I just went here and found Softmax. I asked the other tutor why is there. So he mentioned this is the normal one to use Softmax. Then I checked on the internet and found this equation, this and this explanation, and it was interesting. Okay, fine. Let me finish it because if you go after this, then other things will be pending.
Yeah, 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 of course. But this explanation is very good. The only thing why I put up this question is like I am struggling to understand why we are doing what we are doing
Exactly.
exactly.
What you are saying is good, but so and I would highly encourage you if you can go ahead with your curiosity and find the answer and come back and also let us learn about from you also.
Of
Okay.
course, but I should
Yeah, I think you can correct.
seriously,
Yeah, understand. These are things which everyone is having questions, but like I think we know like few functions only. So sigmoid we know, then few things we know, but you can collect the list of functions and then like how we are using it.
yeah.
Yeah,
For
yeah.
example,
So, yeah.
here we know like softmax we are using for probability, and sigmoid we are using for like couple of classes.
Maybe I can list out all these functions which we are going to
Functions
use
and
or what we have learned so far and why we are using it. Maybe
which
this would be
place, which
exercise
place
for
we
me
use
as well
it.
as for you guys also.
Yeah,
If I
yeah.
can put
Mm.
out some resource on this.
Exactly. Yeah. That would be really nice. Yeah.
Okay, I'll note it.
It's just a learning phase only. Yeah.
Yeah.
Yeah,
Yeah.
I should note it down somewhere before I forget.
Okay. So, and then we are coming to, yeah. So here, yeah. So softmax we got the, and then The commonly used loss function in softmax or for categorical values is categorical cross entropy. This is a default thing also. Generally we use this one. And there are different loss functions mentioned in this link. But this is the defaultly you are using for categorical things. We are using just category cross entropy. Yes, of course, if you want to learn more about this, we need to go into deep into these things and search it out how many different loss functions are there and why you are using those things. Now we are coming to the C part. I think the B part is done, right? You can go ahead with the C part. Everyone?
Yes.
Okay, Yogi ji, are you there?
Yeah, I'm here.
Yeah, is it okay? What you say?
It's okay.
Okay. Yeah. Okay, so we'll go to the third part, and this is the interesting one, very simple one. Okay, so here we have the total number of parameters. They are asking what will be the total number of parameters in the layer 1, layer 2 and layer 3. If I drop out layer, okay, first of all let's check what are the parameters. Parameters are like you see when you find to find a linear function, we have the wx plus b, no? So here b is the bias and w is the weight, right? This everybody knows, right? Guys, answer.
Yeah, proceed, yes.
Yeah. Fine. So w,
Basic linear regression.
yes. So we need to find this w and b, and these are the two parameters we need to find. X is the we already given, so these two things we need to find. So how are you finding the weight? This is the input, for example, and this each line will be the weight, right? This is first somebody was asking the initial line, how are they interconnected? So this is a dense network. Each node, this is a node, input, this is an input layer, this is output layer, this is a node, for example. This is not a deep learning, but this is just a normal neural network. So here we have the inputs connected. This is the inputs, 3 inputs. This is connected to all the neurons, right? So the weights will be this one, for example, will be W1, W2, W3, W4, and similarly we have W5, W6. For each line we will be having separate weights, and each neuron will have one bias value. So in this if you see, we have how many inputs we had? We had 3072 into 50 neurons is the first one, no? First neuron, the hidden layer is 50. So we have the input 3072, and that is how you got 3072 is 32 into 32 into 3. That's the number of inputs, 3072 inputs, and then we have the 50 neurons. So this 3072 is connected to the 50 neurons. So we have total parameters or weights is 3072 into 50, and then we have the bias value. Also the number of bias is equal to the number of neurons. So each neuron will be having each bias, right? 1, 2, 3, 4. Here we have 4 bias in this diagram. This is not related to our question, just for representation. So each this one will be having bias. So each number of neurons will have that number of bias. So this one is clear, this value.
Okay, so there
Bias for each neuron is 1, no? That's why we are taking this as 50 for 15 neurons in the first layer.
They are asking the number of parameters. It's not exactly the value. The parameter, how many parameters are there?
Yeah, so, but in parameter, like in the last, what Professor Manali has told, na? Like bias has to be 1. Value of bias has to be 1. So for
One
each,
during initiation, or is it like only one bias?
no, because the first layer is acting like an initiation layer, so that's why the bias value is 1 for each neuron.
Maybe you are
No, I think
talking.
it is not always 1.
Yeah, it cannot be 1, no?
It is not always 1. Like first, so basically like we have a number of switches is coming as input. Then we have an hidden layer where we are saying as a layer 1. So each layer is having a bias associated to it. The bias is not always 1. We are saying what was mentioned is there's a weight, right? The weight between the input switches and then the input layer. So we are initializing the weight with 1 in the first iteration.
I think what he's trying to tell you is, remember when you apply OLS, ordinary least squares in sklearn. So what it does is it adds a single column where all the number is 1. So maybe he's trying to tell you that the bias value is 1 to initiate. Later on, what it will do is it will use the loss function and then it will try to iterate and then update the bias.
Yeah, we need to find the parameter, no bias and weight. We need to find it out. What is the optimum? That is the final requirement.
Exactly, like in the neural networks also, the first when we were deriving the equations for the neural networks, so that time also what in the class it was told, the initialization is with the help of 1 because it is taken as 1.
Yeah.
Then it is optimized with the loss function.
Yeah, that's good. So what we are doing here is they are asking, the question is like how many parameters are there. They are not exactly asking what is the value of B.
Value is not asked. Right?
Yeah, they are asking the number of parameters, right?
Okay.
So find the total number of parameters. So in this parameters, we need to find how many parameters are in layer 1.
Every neuron will have 1 as its own bias. So plus 50. That is what is the intuition behind this answer. Right?
Yeah, like each number, how many number of neurons are there, that much number of bias will be there, no?
Correct.
That
And
bias will be changed.
Initiated with 1, so 1 plus 1 plus 1 over 50 times is 50.
No. They are not asking the value again. We need not.
But the quantity is 50, no? But the
Yeah.
quantity is 50 again, because if we use 1 initially, then over the 50 neurons, we will find 50 only, no? Even if we sum it or we don't sum it.
No. Don't use the value here. The value is not asked. Value may change once you train it. The value will be changed, no?
Yeah, say suppose X. For one neuron, the bias is X, and for the second one it is Y. So X plus Y plus Z, some so and so. We will have 50 such parameters. So
Yeah,
the answer is
that's the point. How many parameters are there? So here
Yeah.
this is number of biases. How many biases? 50 biases, because we have 50 neurons. And here we have weights. How many weights? Input is 3072 and
Yeah.
50 neurons.
Each
So
will have each will map with every neuron, 50 neuron.
yeah, so 50 into 3072, that is plus 50. So total this much.
Yeah.
I hope it's clear, right?
Yes. It's very clear.
Yeah.
We solved
Similarly,
one question.
similarly for the layer 2 we have 40 neurons, but the input is 50, right? So 50 into 40 will be the number of weights that we need, right? That's the number of parameters. Plus 40 neurons will be having the number of bias will be 40.
40.
So it's plus 40. So 20440. And similar in the layer 3 we have 40 input and 30 neurons, right?
Yeah.
Plus 30 bias. So this is this one. And the totally you just need to add everything and you will get this answer. Okay, and then the question, there is one tricky point here in the question. They have asked, if a dropout layer of value 0.5 is added after the layer 2, what will be the change in the number of parameters? Anyone knows about this dropout layer? I don't think anyone will be knowing, right?
No.
Yeah, the dropout layer is trying to avoid the overfitting. What happens is when you have so much deep learning, then this and the overall performance will be like overfitting of the model. So to avoid that, what it does is during the learning phase, during the training, some of the nodes will be deactivated, and that's called the dropout. So we can give a dropout value. So here they have mentioned a dropout value of 0.1. Oh yeah, 0.5, yes. So but the thing is, for every iteration in the training time, there will be different so many iterations that is happening, right? So in each iteration, the different number of nodes will be deactivated, and these weights will remain there, but this deactivated, hence it will not affect it.
So half of the nodes will be dropped.
Yeah, dropped, but it will be again during the iteration, during the training time, there will be different iteration. There will be thousands of iterations going on, and these nodes will be finally in the model, all the nodes will be active. So in the final, during the testing time, all the nodes will be active, and hence all the weights will be used. So there is no change in the number of parameters.
Is it by any chance related with this back propagation? I mean,
No, right now we are only using the feed forward. No,
okay.
in this question is related to the feed forward, right?
Okay.
So there's no change in the, they have mentioned here, the answer is no change in the number of parameters if dropout is added. And the reason I just searched and found this is the reason. Because by dropout we are trying to avoid overfitting in the deep neural network. It is similar to L1 and L2 regularization. In dropout, the dropped out nodes weights remain but are not affecting, shown by the dashed line. In this YouTube they have mentioned it. Dropout affects only during training to fit the model.
Okay.
So during test, all nodes and weights are
Contribute.
in play. Yeah.
So this question is specifically related to testing, is it? Or
Testing is not
they have
mentioned, no?
specified anything?
Yeah, so we have to say that finally what will be the once the model is trained, we all the parameters are in place.
We have to just
Basically, the neurons are still in place.
Yeah, all
It
the
is just disabled.
yeah, just because during the training phase, for each iteration, some neurons will be disabled. 0.5 number of neurons will be disabled, and
Unlike L1, where it just drops out those parameters or features in L1, like if the weight is becoming low, it just puts it to zero and just drops that feature all of a sudden. So it won't do that. It will keep those neurons. But just so it won't overfit the model, the training model. That's what the whole idea about this.
yes.
Okay. Can you just try to recall, like, can you just try help me to understand, like, this L1, L2 regularization, maybe you can just brief, so I can just recall.
Yeah,
L1 is lasso and L2 is ridge. So what lasso does is it will try to learn and iterate over the absolute value of those weights. If suppose your weight is increasing, then it will try to reduce those features so that your entire cost function is low. Okay, so when you see
Okay.
the L2, it squares. So in unlike L1, the L2 is trying to square up those weights. When your weight is increasing, so it will add and it will square those weights. So your entire cost function is not exactly zero, and your weight will also not go to zero. In L1, the weights are zero, so the features related to those weights drop and they just vanish from the training model. L2, in case of L2, it doesn't happen like that. L2 keeps your weight and keeps your features there with lower weight, very low, small percentage. It will keep it.
Okay. One is lasso, the other one is
Ridge operator.
ridge.
L2,
Okay.
yeah.
Got it.
L2 norm. Yeah.
okay. The last question in this question is what is the difference between kernel regularization and activity regularizer? Actually, I don't know about it. I couldn't get the time to go through this. Kernel regularizer is to apply a penalty on the layer's kernel activity layer's output. So basically, this guy has mentioned something. Dropout layer.
In this data science, the kernel is mentioned in so many places that it sometimes gets very overwhelming to know exactly what do they mean by kernel. In Jupyter Notebook also you see kernel.
Yeah, regularization to control the can anyone read this cuteness in values y is equal to w plus x plus b. Kernel regularization will put penalty of weights that are huge. Okay, activity regularization penalize very high outputs. Okay, so kernel regularization means it will put penalty on weights that are huge. So weights is the individual node input of the node, right? So that will be penalized by the kernel regularization, and then for the output, if it's high, it will be penalized by activity regularizer. Bias regularizer, what is this? Penalize high bias value. Okay, so for the one more, okay. So they have asked only kernel and activity, but he has mentioned bias also. It will be regularizing the bias. Because if these values are too high, then it will be overfitting. No?
I don't know. Maybe do you remember kernel? I mean, when you read it, do you understand what kernel is? Because as I said, it's very overwhelming topic for me. Everywhere I read kernel, but I don't exactly understand how does it work. Like in one place, I remember there is this kernel trick they told, no? When in case of the polynomial function is coming, they will just use that polynomial as a linear variable, so it gets into a linear model. Remember, I don't know, maybe.
That is a kernel trick, right?
Yes, yes, yes.
That was used in where was it used? SVM or
No, no, it's used in this. It is used in SVM as well, but I read it back in linear regression when in that PRML book, pattern recognition and
in
machine
the
learning. No?
SVM? Yeah, in this SVM, I think it's they have the I guess that SVM non-linear SVM. Yes, it's
Hmm.
they have the how to use this one. Yes,
I think
it's
this is
mentioned.
a plane which is separating two different items, right?
Yeah, so
Something
in the
like a
non-linear
circle.
SVM, there has to be curve, no? So that's why they are using the trick, kernel trick, to have the non-linear performance.
But what is kernel exactly? I mean, is it just expanding the dimension is called kernel, or what? I mean, I don't really get that word, how it is
Actually, we
used,
don't know.
because
Maybe they have just coined up a word, I think.
it's important because first of all, in machine learning, the notations took out half of my time to understand the notations. Andrew Ng says something, and then this Euler guy says something. Tom Mitchell uses another notation, so it's very, very cumbersome to get along with.
Yeah, that's right. Because there's so many of different words are used for the same thing. Yeah.
So I
Because
think what I read in the internet is kernel is something like a filter which is used to extract the weights or parameters from the input data.
Can you come again, please? I mean, I'm trying to
Okay.
understand.
Kernel is something like a filter,
Filter, okay.
okay, which is used to extract the parameters or features from the input data.
Okay.
So basically, we can say like we have a linear regression. They're trying to identify the weights, right? So W0, W1, W2, something like that. It's not my understanding after reading this.
Okay. No, please go on. Maybe that can help lead some understanding. So as a filter, okay.
Mm. So the weights of the kernels are okay, for this specific feature. Okay, the input kernel is designed to detect a specific features in the input data, such as edge, corners, or other patterns.